Welcome back to part 2. So we looked at the first 4 rules: constant rule, power rule, constant multiple rule, sum and difference rule. And now we're going to take a look at the product rule, which is a little bit more complicated because we're talking about 2 functions being multiplied together. So some books like to call them u and v. So let's let u and v be 2 distinct functions of x. Well, here's what most of us wishes were true. Most of us wish that we could just find the derivative separately and then multiply them together, just like we did with the sum and difference. But the reality is that's just not accurate. It's not correct. It won't give you the right answer. Instead, what you're going to have to do is find the derivative of one, multiply it to the other, and then add that to the derivative of the other multiplied to the first one. So it's basically just a combination of one derivative, one regular, the other derivative, the other regular. U prime v plus v prime u. And some other books might have that written as f and g, so I want you to be familiar with everything, no matter what it looks like. Some books have it written this way: f prime g plus g prime f. So it's basically just derivative of the first times the second plus derivative of the second times the first. It's not too bad, actually. U prime v plus v prime u, or f prime g plus g prime f. Let's go ahead and try that out in this example 5. Now, you might be looking at this and asking yourself, well, can't I just FOIL them and use sum and difference method? And the answer is yes, and that might even be easier than product rule. But when we get to other types of functions, like if you flip ahead in your book to sections 3.5 and 3.6 and 7 and 8 and 9, you're going to have trig functions, trig inverse functions, exponential functions, logarithmic functions. That won't work in those instances. We just haven't learned all those formulas yet. So we're just going to practice this product rule on what we do know. So yes, you could FOIL and just do sum and difference. But for the sake of learning how to use product rule, we're going to do that here on what we already know how to do. So I'm going to call this first function u and then this second function v. And then I like to keep track of my u prime and my v prime. I write them down. Trust me, you're going to want to do that to avoid making mistakes. So if I use the sum rule and the power rule, I can find the derivative of u very easily. Just take the power, move it in front, and drop it down by 1. So I get 2x plus 0, because derivative of a constant 0. Then I come over to v and I do the power rule again. So I get 3x to the second and then plus 0. So now f prime of x is going to be u prime times v. So it'll be 2x times x cubed plus 3 plus 3x squared, which is v prime times u, which is x squared plus 1. And then now we'll go ahead and distribute and simplify. So then we get 2x to the 4th plus 6x plus 3x to the 4th plus 3x squared. Combining our like terms, we get 5x to the 4th plus 3x squared and then plus 6x. And that is our derivative of this function with respect to x. And that's product rule. Let's move on to a problem like this, example 6, a very classic sort of AP type question, because it doesn't tell you what u and v are. It just gives you the values of their original functions and their derivatives at x equaling 2. And so what this is testing is to see if you know the rule in its general form. It wants to just know, do you know what the rules look like for generic functions? And we do know. We know that the derivative with respect to x of u times v, we know that that generally looks like this: u prime v plus v prime u. That's what I mean by know what the rules look like in their general form. Be able to write them out in terms of the functions. Okay, but it wants me to find the values. This is looking for a numerical value, so I'm going to evaluate this when x is 2. That's what that little line means. Evaluate when x is 2. Well, u prime of 2, that's right here. That's negative 4. So this is going to become negative 4. Regular v of 2 is 1. Plus v prime of 2, derivative of v at 2 is 2. And then regular u of 2 over here is 3. So the derivative with respect to x of the product of u and v, evaluated at 2, ends up being negative 4 plus 6, which is 2. Okay, moving on to part B, which is like combining all kinds of stuff. We've got constant multiple rule, sum and difference rule, and a product rule right here. So we're going to write out in general what all those rules say. The first rule says that's just going to be the constant times the derivative of u. That's just 3u prime. Here, let me write this down here, actually. That's going to be 3u prime. The sum and difference rule says just subtract the derivative of this next thing. And the constant multiple rule says, well, that's just 2 times v prime. 2 times the derivative of v. So I use the constant multiple rule, the sum and difference rule. And then now I'm going to use the product rule, and I'm going to let this 2u be like my first function, and v would be my second function. Derivative of 2u would just be 2u prime, and then times v, plus derivative of v, which would be v prime, times that first function, 2u. So I basically just used constant multiple rule, sum difference rule, and product rule, and now I'm going to evaluate all of that when x is 2. So again, the derivative of u, or u prime at 2, is negative 4. So I have 3 times negative 4. Minus 2 times the derivative of v at 2, which is 2. Plus 2 times the derivative of u at 2, which is negative 4, times regular v at 2 over here, which is 1, plus derivative of v at 2, which is 2, and then times that 2, and then times regular u at 2, which is 3. So I get negative 12 minus 4 minus 8 plus 12. So these guys basically cancel, and I have negative 12 as my answer to part B. So that was utilizing all the rules in their general form. You need to be able to do that. That's a huge skill that this book will require of you, and the AP test will require of you as well. Moving right along to the infamous quotient rule, which people tend to not like as much as product rule, and you'll see why. That is if you have a derivative of the quotient of 2 distinct functions. Again, we all wish we could just take the derivative of u, take the derivative of v, and divide them, and that would be totally wrong. So it just doesn't work that way. Instead, it begins similar to the product rule, u prime v minus v prime u. So we have the same combination, it's just we're subtracting versus adding, and then that all has to be divided by v squared. And that's your quotient rule right there that you're going to have to memorize. You gots to know your quotient rule. Now, again, just to stay, consistent with other textbooks, sometimes you'll see this as f prime g minus g prime f all over g squared. So I want you to be able to be comfortable no matter how you see it written. And then a common or popular mnemonic device that my students taught me, actually, that they learned, is if you have basically a quotient rule. You have something on the top, something on the bottom. So the one on top is high, the one on the bottom is low. Well, the derivative little thing goes high and then d low. High d low minus low d high all over low squared. So it's the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. High derivative of that, low, minus low derivative of that, high, all over low squared. High d low minus low d high over low squared. Hopefully that will be helpful to you. Some people just have an easier time going u prime v minus v prime u all over v squared. So stick to whatever is easiest for you. And we're going to go ahead and practice using that again with some polynomials because that's what we're familiar with at this point in example 7. So let me just get this G out of the way there. Okay. So we have and what I do, by the way, when I'm doing quotient rule is I keep track of everything. I write down u is x squared plus 5x minus 1. V is x squared minus 2. U prime, I go through and I find the derivative piece by piece. So that's 2x plus 5. V prime, I go through and find the derivative piece by piece. So that's 2x. Then I go ahead and I write out the formula. U prime V minus V prime U all over V squared. I do this every time and I teach it. So something you want to consider doing. Okay, so I've got 2x plus 5 times x squared minus 2. That's u prime v. Minus v prime u, which would be 2x times x squared plus 5x minus 1. All over v, which is x squared minus 2 squared. Yes, we need to simplify that. So as we work to simplify that, we end up with, let's see, that'd be 4x, or negative 4x, plus 5x squared. Oh, I forgot the 2x cubed. I don't know why I missed that. So we had 2x cubed, negative 4x, 5x squared, negative 10. Okay, and then here, don't forget to distribute the negative along with the 2x. You have negative 2x to the third, negative 10x squared, and then positive 2x. And then, of course, that's all over x squared minus 2 squared. Well, the 2x cubes, those cancel out right away. And let's put the x squareds first. So I have negative 5x squared. So that took care of these guys. And then I have negative 2x, which takes care of those guys. And then I'm left with that negative 10. All over x squared minus 2 quantity squared. And so that right there is our dy dx, our derivative of this y with respect to x. And that is how quotient rule works. Okay, last piece of information for this section is, now sometimes we can go beyond, actually oftentimes we go beyond just a first order derivative. We can take second derivatives, third derivatives, we can take as many derivatives as we want. So notation, basically, y prime is our derivative of y. So you might see y double prime and wonder what the heck that is. Well, that's the derivative of y first prime, I guess you could say. Y single prime. Or the second derivative of y. So this first derivative, second derivative, which is just the derivative of the first derivative, and so on. That's one notation. You might see this way. So dy dx, again, is derivative of y with respect to x. So then if you see this, the d2y over dx squared, that's the derivative of dy dx with respect to x. So it's the second, it's the notation for the second derivative using the dy dx notation instead of the y prime. And so that's just a little note on notation. And so, for example, 8, it's using the dy dx and the d2y over dx squared notation, but that just is basically asking for a first derivative and a second derivative, which is the derivative of the first derivative. So we have to go in order. So first we'll find dy dx, which is just using power rules, going step by step. So you get 2x plus 1. And then the second derivative, which is the derivative of the first, would just be 2. And that's really all there is to it. You just take the derivative of the first one. And with polynomials, the derivatives get easier and easier to find as you go further and further. Okay, so I'd like you to try one actually right here before we call this quits. I'd like you to go ahead and try finding both f prime and f double prime for this function, which would require the quotient rule. So I'd like you to pause the video here and try finding both the first derivative and the second derivative for this function, which would require the quotient rule. So go ahead and try that now. When you come back, I'll give you the answers. So for the first derivative, you should have gotten -2 divided by x minus 3 quantity squared. That would be our first derivative. For the second derivative, you should have gotten 4 divided by x minus 3 quantity to the third. So hopefully you did well on those. If not, you can check how to do them in tutorial. And I will see you in class on Monday. Have a great weekend.